Good day, good people. My name is Kabasekwele and I'm an online math tutor here to help young children turn their struggles into their successes. Today we're going to be discussing ratios and rates. My aim with this video is to help children understand what ratios are, because I truly believe to do well in mathematics you need to understand. So this video is going to share the more theoretical side of ratios so that they can apply their theoretical understanding practically. And by practically I mean solving problems. They can't solve ratio problems and tests if they do not understand what ratios are. So that's the whole point of this video today. We're going to be discussing ratios and rates, but we're going to start first with talking about ratios. There is a slight difference between the two, so let's start first with ratios. Ratios and rates are the comparison side of mathematics. Ratios compare values that are of the same kind. A ratio will compare a measurement to a measurement, or an apple to an apple, or a size of something to the size of another thing. It must be the same type of value in order for it to be called a ratio. So for example, if you have a bowl of fruit, and this bowl of fruit has 8 oranges and 6 lemons, the comparison of orange to lemons would be 8 to 6. But to see the truest comparison, you need to turn this fraction into its simplest form. By seeing it in the simplest form, it just helps you see the comparison better. So 8 to 6 in its simplest form would be 4 to 3, which basically means for every 3 lemons in the bowl, you have 4 oranges. So what are the different types of ratios? The first type is what I like to call part to part. This is when you compare a part of a whole to the other part of the same whole, which is why we call it part to part. You're comparing a part to a part. So going back to our example of the fruit bowl, if a bowl of fruit contains 8 oranges and 6 lemons, their part to part ratio would be 8 to 6, because like we said previously, the total number of fruits is 14. 8 is a part of the 14. The oranges are a part of the whole bowl of fruit. Therefore, 8 is a part of the total. Also, the lemons are a part of the whole bowl of fruit, which is why 6 is a part of the 14. Therefore, you're comparing 2 parts together. Now, the second type of ratio is what I like to call the part to whole. This is when you compare a part of the whole to the whole. So, for example, if a bowl of fruit contains 8 oranges and 6 lemons, the part to whole ratio for the oranges would be 8 to 14. 8 being the number of oranges and 14 being the total number of fruits. And then again, the part to whole ratio for the lemons would be 6 to 14. 6 being the lemons and 14 being the total number of fruits. Now, a very important form of ratios is called equivalent ratios. This is when two ratios look different but they're actually exactly equal. For example, we have 2 to 3. The ratio 2 to 3 is exactly equal to the ratio 4 to 6. 4 to 6 is exactly equal to 8 to 12. So these ratios are all equal to one another. Their value is equal, but they look different. These are very, very, very similar to how equivalent fractions work together. For example, 2 over 3 would be equal to 4 over 6, and 4 over 6 would be equal to 8 over 12. See, all of these fractions are equal to one another, but they look different. So for us to have the first equivalent fraction 2 out of 3, and the second equivalent fraction 4 out of 6, we multiplied 2 by 2 and that gave us 4, and then we multiplied 3 by 2 which gave us 6. That's how we found the equivalent fraction of 2 out of 3. Equivalent ratios and equivalent fractions work exactly the same. For example, let's say you wanted to find the equivalent fraction of 2 out of 3. To do that, you would multiply both the numerator and the denominator by the same value. So for example, let's multiply 2 out of 3, and we're going to multiply both those values by 3. So 2 multiplied by 3 is equal to 6, and 3 multiplied by 3 is equal to 9. Therefore, an equivalent fraction of 2 out of 3 is 6 out of 9. The key is to multiply both the numerator and the denominator by the same value. If you multiply the numerator by a different value than you multiply the denominator, the fraction is not going to be equivalent. You've now changed the value of the second fraction. That's exactly how equivalent ratios work. The key is to multiply it by the same value so that you can keep the value of the ratio equal. To find a ratio's equivalent, you would need to multiply both values in that ratio by the same number. Once again, let's say we have a ratio of 2 out of 3. We're going to multiply both those values by 4. Therefore, 2 multiplied by 4 would be equal to 8, and 3 multiplied by 4 would be equal to 12, which thus means the equivalent ratio for 2 out of 3 is 8 out of 12. That's how you find equivalent ratios. That's what ratios are basically, and if you need more of an understanding, I suggest you look into this video, because in here I explain the foundation of ratios, which is division. Division is the foundation of a lot of topics in mathematics, including ratios and rates. So please be sure to go down to that video and it will give a better explanation of how division and ratios relate to one another. Now we're going to move on to rates. Let's talk about what rates are and the differences between ratios and rates. While ratios compare values that are of the same kind, rates compare values that are of different kinds. Rates compare all sorts of things to one another, whereas ratios typically compare things that are of the same whole. And just like ratios, we need to turn rates into their simplest form in order for us to see a better comparison of the things that are being compared. Now remember the example that we use of the bowl of fruit? The oranges and the lemons all came from a total of 14 fruits. Therefore, they all came from the same whole. Whereas rates do not work like that. Normally, rates are used to compare something to time, but obviously can be used for other things as well. For example, a question may ask, what is the rate of a car if it drove 30 kilometers in 3 hours? You are comparing distance to time. You're comparing the kilometers to hours. And this question is basically asking you, if this car drove for 30 kilometers in 3 hours, how many kilometers did it drive in 1 hour? So, to find the answer to that question, we would divide both sides by 3. I'm not really going to get into why I chose 3, but to give you a clue, think of the highest common factors. If I got into that, the video is going to be way too long. Please be sure to go do more research on what is called the highest common factor. But in this case, I'm going to divide the kilometers by 3 as well as the hours by 3. Therefore, 30 divided by 3 is equal to 10. And 3 divided by 3 is equal to 1. In other words, for every hour, the car drove 10 kilometers. Now here's a note that I want you to remember. Never confuse ratios for rates. Although they are similar because they both compare values, they are not the same. However, the foundation for rates is also division. So if you want a better understanding of how rates work and the foundation of rates, please once again go to this video and I hope you'll get a better understanding of that. Thank you so much for making it to the end of this video. If you are in search of an online math tutor who can help you understand mathematics, please be sure to go down to my website, schedule a free consultation with me, and I will see you then. Thanks once more. I'll see you in the next video.